Okay, let's dive into this. Welcome to today's Explainer. We are tackling a seriously mind-bending text today, all about the absolute, ultimate limits of technology. If you've ever found yourself wondering not just how the next generation of supercomputers is going to work, but what they fundamentally represent on a literal cosmic scale, well, this source material has some incredibly fascinating answers for us. It basically frames quantum computing not just as some cool tech upgrade, but as the final frontier of how we interact with the universe itself. Just listen to this philosophical claim from the text. Quantum computers are the last step humans can make in digitizing reality. That is just massive. We usually think of computing as, typing on a keyboard or swiping on a piece of glass, but this author is arguing that we are approaching the absolute endpoint of translating the physical world into digital data. So let's zoom from the macro scale of the entire cosmos all the way down to the microscopic mechanics to figure out exactly why. Section 1. Digitizing Reality's Elastic Fabric, the Cosmic View. Now, what's really interesting about this is how the source grounds some highly abstract physics into a really vivid physical definition. It describes reality itself, like the entire universe, as simply a three-dimensional elastic fabric that's capable of change. So picture less of a collection of rigid floating billiard balls and more like a giant cosmic waterbed. Every single thing that happens, every movement, every calculation, is ultimately just a stretch or a ripple within this elasticity. And that completely reframes what a computer actually is, right? We aren't building a machine that sits outside of reality, we're literally manipulating the fabric itself. The text maps out this wild, unbroken evolutionary chain happening entirely within that exact same fabric. First, we start with simple waves rippling through the medium. Second, those waves create local structures, which eventually build up into incredibly complex things, like us. And finally, from our perspective, we figure out how to combine these structures even further to create supercomputers. It's just wild to think about it this way. The fabric ripples, the ripples form human beings, and then the humans organize those ripples into quantum machines. It's like the universe is quite literally figuring out how to compute itself. Section 2. Qubits as Local Distinctions, the Microscopic View. And this brilliantly illustrates what happens when we zoom all the way in. At this microscopic level, the mechanics are wild. Even through all of our complex engineering, reality remains fundamentally itself. The fabric doesn't change. But here is where human ingenuity actually steps in. The text explains that we locally assign shapes within that fabric. Imagine drawing a tiny conceptual circle around a ripple and declaring, okay, this is now a qubit. We take these distinguished shapes and we force them to interact. We are directly mapping human logic onto the tiniest shapes of the universe, which completely reflects our understanding of how nature behaves at its absolute lowest level. Section 3. Continuous Nature, Discrete Calculator, the Machine View. We are dealing with a really profound contradiction here, and I want to slow down to emphasize this paradox. On one side, nature is an elastic fabric, right? It flows and it is full of continuous statistical noise. It is messy. But on the other side, we have our human desire for a discrete system. We want a calculator that gives us a clear, perfectly predictable answer. A simple yes or no. The text points out that we are literally trying to force a continuous, noisy reality to perfectly mimic a highly predictable calculator. It's like trying to force crashing ocean waves to turn the rigid, precise gears of a clock. It is an almost impossible feat of engineering. So the crucial point is, there's a major caveat here. This universe-bending machine could actually work if, and that's a big if, we can actually formulate the problems for it to solve. Remember, the interactions of these qubits only produce a calculator for problems that we assign to them. Because we absolutely need answers in a discrete yes or no format, we have to perfectly translate our messy real-world questions into a language that this continuous statistical machine can process predictably. So the hardware, that's really only half the battle. The true limitation is human translation. Section 4. Wealth versus Real Problems, the Human View. We've traveled all the way from the cosmic elastic fabric, down to the tiny interactions of qubits, and back up to the massive paradox of building a machine out of continuous noise. But our source text pivots right at the end from grand philosophy to a highly pragmatic, everyday question. Look, mastering this ultimate technology is undoubtedly going to be profitable. A quantum computer can absolutely make people richer, no question. But formulating the exact problems for it to solve is incredibly difficult. So, the ultimate question is this: can it actually calculate in a way that solves real, meaningful problems for humanity? Or is digitizing reality just going to be the world's most complicated wealth generation tool? Think about what you would actually want this ultimate technology to achieve, and ask yourself what problems you would assign to the very fabric of the universe. Well, something to chew on. Thank you so much for joining me for this explainer, and I'll see you next time.